I'm working through the organic chemistry section of the first version of the 2020 chemistry paper, and the first part of that organic chemistry is naming and structure of compounds, which starts with 3 multiple choice questions, 1.1, 1.2, and 1.3. Question 1.1 reads, which one of the following is the general formula for alkanes? And the general formula for alkanes is always CN, H2N plus 2. There are always N carbons and there are always 2N plus 2 number of hydrogens in an alkane. Question 1.2 reads, the empirical formula of hexanoic acid is, and it's often easier just to draw this for ourselves, and hexanoic acid would have meth, eth, prop, bute, pent. Hex, as we can see, is 6 carbons. In order for it to have an anoic acid, we know that it must be carbon double bonded to an oxygen and single bonded to a hydroxyl group. And once we've done this and drawn in the additional hydrogens, we can then see that hexanoic acid would have 6 carbons, 2 oxygens, and 12 hydrogens, which means the answer to question 1.2 is then C. Question 1.3 reads, which one of the following is the correct structural formula for methyl ethanoate? And as we can see, methyl ethanoate must be an ester, where the part attached to the YL, meth in this case, is the part of the ester attached only to the single bond oxygen. So that is a single carbon attached to a single bond oxygen, and ethanoate is attached to the double bond oxygen, meth, eth, attached to our double bond oxygen. And now we can see which one of these this resembles, and we can see here that this is the inverse of option C, just drawn the other way around, which makes the correct answer to question 1.3 option C. We then go on to the naming and structure for organic molecules, and that starts at question 2, where question 2 reads as follows. The letters A to E in the table below represent 5 organic compounds. As we can see, they are given here. Use the information in the table to answer the questions that follow. Question 2.1, for compound D, write down the homologous series to which it belongs. And as we can see, compound D over here, pentan 2-one, and we draw that pent, meaning that there are 5 carbons, and with the suffix anone, we can then see that that must be a ketone with the double bond oxygen on the second carbon, pentan 2-one, which means that the homologous series to which this belongs is then the ketones. We know that as soon as we see this carbon-oxygen double bond, the carbonyl group, that must be a ketone. Question 2.1.2, the IUPAC name of the functional isomer, and the only possible functional isomer for a ketone would be an aldehyde, where that carbon-oxygen double bond is then moved to the first carbon, and so we can draw that for ourselves. Once again, it must have 5 carbons, where now that carbonyl group is on the first carbon, where we then call it a formyl group, and so as we can see, this then becomes an aldehyde, still with the prefix pent, but now because it's an aldehyde, it gets the suffix anal, pentanol. And now we do not need to call this pentan 1L, because aldehydes are defined by having this carbon-oxygen double bond on the first carbon, so we do not need to indicate the position of that bond. Question 2.2, write down the IUPAC name of compound A, and as we can see here, compound A, we start out by naming the longest carbon chain, that longest carbon chain being meth, eth, prop, bute, pent, hex. We can see that there are only single bonds present in this chain, so we know that the name here is going to end with hexane. We can then see that there are 3 branches or different groups attached to this main chain. One of those is a bromo group, and there are 2 methyl groups, and we need to arrange those alphabetically. Alphabetically, bromo would come before methyl, and so this is going to be bromo, and then as we can see there are 2 methyl branches, so bromo dimethyl, and now we need to pick our numbering, and we can see that if we number from this side as carbon number 1, then these would be 2, 3 dimethyl and 5 bromo, which gives us a smaller number combination than calling this 2 bromo and 4, 5 dimethyl hexane. And so the correct name here for compound for compound A would be 5 bromo. Remember that this is all written as one word, as it is one compound. 5 bromo 2, 3 dimethyl. And as we said, this main carbon chain is a hexane chain, dimethyl hexane. So the correct name here, 5 bromo 2, 3 dimethyl hexane. Question 2.2.2 reads, write down the structural formula of compound E. Now compound E, we can see contains 5 carbons in its longest chain. There is a triple bond present, represented by the YNE, meaning it is an alkyne. The triple bond is on the 2nd carbon, and there's a methyl group on the 4th carbon. And so we would name this, or we would draw the structural formula by starting with our 5 carbon chain: meth, eth, prop, bute, pent. Then showing that we have a triple bond present on the 2nd carbon, triple bond represented by 3 lines to show the shared electron pairs, and then finally to show that there is a methyl group on the 4th carbon. And then whenever we draw structural formula, we ensure that we draw all of the necessary hydrogens in to ensure that every single carbon has formed exactly 4 bonds. And there we have 4-methyl pent 2-ine. Question 2.3.1. Compound B is a primary alcohol. Write down the meaning of the term primary alcohol. And a primary alcohol is one in which the hydroxyl group that is attached to a carbon that is only attached to one other carbon. So we're saying that the carbon to which this hydroxyl group is attached, if we draw this here, we can see that it is 3 carbons. And they've told us it's a primary alcohol, which means that our hydroxyl group must be on the 1st carbon. And so our definition for a primary alcohol is one in which the carbon that is attached to the hydroxyl group is only attached to one other carbon. Question 2.3.2. Write down the type of reaction that takes place when compound B reacts with another organic compound X to form compound C. Now, compound C, as we can see here, is an ester, defined by this ester group in the middle. And since we know that this is an ester, the only type of reaction that can take place here when we start with an alcohol is the reaction between an alcohol and a carboxylic acid to form an ester and water. And so this reaction is called an esterification reaction. Question 2.3.3, write down the IUPAC name of compound X. And now since we know what the alcohol was that this came from, that being compound B, we also know that the alcohol is always responsible for the part of the ester that is attached only to the single bond oxygen. So this over here, as we can see here, we had propan 1-ol, and this has become propyl, and now that leaves us with a 4-carbon chain that is attached to the double bond oxygen that must have come from our carboxylic acid, and a carboxylic acid that contains 4 carbons we know is called butanoic acid. There are a number of common errors that are made in the first section of organic chemistry. The most common one is neglecting to include all of the hydrogens. One must ensure that every single carbon has formed only 4 bonds, and we do that by attaching hydrogen bonds wherever there are not 4 bonds on a carbon. Another common area for mistake is when asked to name a compound that we leave spaces where there are not spaces. So we need to show very clearly that this is 5-bromo, that is all one word, there should not be any spaces, 5-bromo 2,3-dimethyl-hexane. And the way we remember this is we say that between letters there are no spaces, between numbers there's a comma, and between numbers and letters there must always be a hyphen.